Exam 4 review, question number 40. Use transformation to write a logarithmic function base 10 from the graph below. Assume no stretching. So the first thing you notice is the vertical asymptote. We know that the vertical asymptote, this is a logarithmic function. So the vertical asymptote comes from making, so we have this is x equals -1. That is x equals -1. That is the vertical asymptote. And we know that the vertical asymptote comes from making the argument equals to 0. So we're going to reverse. We're going to add 1 to make one side 0. So we get x plus 1 equals to 0. This is the argument of the log. So we have so far f of x equals log base 10 of x plus 1. That's what we have so far. We know that there was a vertical movement of the graph. So I'm going to say plus a here in general. And then I will try to use that point. So use the point 0 and -2 to find a. So we have the function f of x equals log base 10 of x plus 1 plus a. If you use this point, you're going to get -2 equals log base 10, 0 plus 1 plus a. -2 equals log base 10 of 1 plus a. And we know that log is equal to 0. Log 1 is equal to 0. So we get -2 equals a, which means the function will be log base 10 of x plus 1 minus 2. Question number 41. It uses an exponential function. So the exponential function base 2 in this case, which means the parent function is f of x is equal to 2 to the x power. Since we're looking at an exponential function, we know that there are horizontal asymptotes that represent a vertical shift. So in this case, the horizontal asymptote is y equals -1, which is basically the vertical shift of the function. So I'm going to say -1 immediately. But then you notice again that there was a horizontal shift that affects the x value. So I'm going to say the new function is going to look like x plus, let's say, a again, and we're going to find that a. Also notice how the parent function of 2 to the x power is the green one here, which means we had a reflection across the x-axis, which means there is a negative in here. So in general, the function is going to look like -2 to the x plus some a that I will find -1. Now, in order to find that a, I will use this point. So use the point 3 and -2 to find a. So we have -2 equals -2 raised to the 3 plus a minus 1. To solve, I will add 1 to both sides of the equation. You will get -1 equals -2 to the 3 plus a. We can rewrite -1 as -2 to the 0 power, so we can have similar exponents. Now, by comparison, we have the same base, which means the exponents are the same. So we're going to put 3 plus a equals 0. If you subtract 3, you get a equals -3. In other words, the function is -2x minus 3 minus 1 is the equation of that function. Exam 4 review, question number 43. Show that log base e of x divided by log a over b of x is equal to 1 plus log base a of 1 over b. Now, when it comes to showing or proving that one side is equivalent to the other, you're going to start from the left-hand side and work your way to get to the right hand side to prove that they're equivalent, or backwards. Sometimes it works backwards as well. However, I will start with the left hand side. The left hand side equals to log base a of x divided by log base a over b of x. I can rewrite this as log the numerator minus log the denominator using the quotient rule. Now, I would like to work on this expression, and I noticed that there is a base in this case, which means I can basically use the change of base formula to change that into division of logs. So log base a of x remains the same, and I can rewrite this as log base a of x, I'm using base a here, over log base a of a over b. Now I have that. I can turn that into subtraction of logs, so it's going to be log base a of x minus log base a of x minus log base a of a over b. And now I'm going to distribute the negative inside, so you will have log base a of x minus log base a of x, which will be 0, plus log base a of a over b. So now these two will cancel out, and I will end up with only log base a of a over b, which and then I can turn into a subtraction of logs. So it's going to be log base a of a minus log base a of b. Now, I know log base a of a is equal to 1, so this is going to be 1 minus log base a of b. However, it doesn't look like the right-hand side yet. However, I can still manipulate that. So I know that if I take the negative 1, if I write it like 1 plus negative 1 log base a of b, then I can use the reverse of the power rule, and I can put the negative back in there. So it's going to be 1 plus log base a, b to the negative 1 power, which now it turns into 1 plus log base a of, I can write b to the negative 1 as 1 over b, and this is exactly the right-hand side. So I started from the left-hand side, and I showed that it's similar to the right-hand side, and that's exactly what's needed.